we're going to see the derivative of inverse function of sine of x, cosine of x, and tangent of x. So the first one is y equals to sine to the minus 1 of x, or arc sine of x. So we can do implicit differentiation. Would be easier if we put x is equal to sine y. So derivative of x with respect to x is 1. Derivative of sine y with respect to x is cosine y dy dx. So dy dx is equal to 1 over cosine of y. 1 over cosine of y is the same as 1 divided by what's cosine of y? Square cosine of y plus square sine of y is equal to 1. Square cosine y is equal to 1 minus square sine of y. Cosine of y is equal to the square root of 1 minus sine square y. So dy dx is equal to 1 divided by square root of 1 minus square sine of y. But sine of y is equal to x, so dy dx is equal to 1 over square root of 1 minus square x. So this is the derivative of inverse function of sine x. Now for cosine x, the derivative of inverse function of cosine x. So it would be, let's say, we would put g of x is equal to cosine to the minus 1 of x, or arc cosine of x. So again, would be x equals to cosine, I would put cosine of g. So inverse differentiation, implicit differentiation is derivative of x1, derivative of cosine of g is minus sine g dg in dx, and this is what we want to find, the dg in dx. So 1 divided by sine of, or 1 divided by minus sine of j is minus 1 divided by sine of g is equal to dg dx. Again, what's sine of y? With this, we have square sine of y is equal to 1 minus square cosine of y. So sine y is equal to square root of 1 minus square cosine of y. So here dg dx is equal to minus 1 divided by square root of 1 minus square cosine of y of g. Here I did it with y, but it's the same for x, y, whatever. So minus 1 is minus 1 divided by what's cosine of g? X. So divided by square root of 1 minus square x. So the derivative of the inverse function of cosine x and sine x is exactly the same, just with different sign. And now for tangents, this is a little bit more hairy. So we have y is equal to tangent to the minus 1 of x, or arc tangent x. So x is equal to tangent y. dx is 1. Derivative of tangent y with respect to x is square secant of y. dy dx. So dy dx is equal to 1 over square secant y is cosine square y. Remember, here we have a 1, and so we can put this as cosine so now we were doing the derivative of inverse function of tangent x. Here we have x equal to tangent y. Derivative 1 is equal to square secant y dy dx. We put this in the other side, and we have dy dx is equal to square cosine y, but we have a 1 that is divided here, so square cosine y divided by square cosine y plus square sine y. And we can multiply everything by a combinant 1. We have 1 divided by square cosine y divided by 1 over square cosine y. So square cosine y divided by square cosine y is dy dx is equal to 1 divided by cosine square y divided by cosine square y is 1, plus sine square y divided by cosine square y is tangent of y, square tangent of y. So we have dy dx is equal to 1 divided by 1 plus what's tangent of y? X. So square x. So it's similar to the derivative of inverse function of cosine and sine. Is similar to the derivative of inverse sine, just that without the square root in the denominator. So the derivative of inverse function of sine x is 1 divided by the square root of 1 plus square x. Of the derivative of inverse function of cosine of x is minus 1 divided by the square root of 1 plus square x. And the derivation of the inverse function of tangent x is 1 divided by 1 plus square x.